All right, let me just show you how to solve inclined plane problems. Here you've got some object with a mass of m. Whoa, sitting on this plane, right? Okay, and the force of gravity is, of course, going to act straight down, and that's going to be mg, right? But the object can't go straight down. It can only move along the plane. So part of this force, because the plane is tipped, is actually part of that force, right, is along the plane, right? And I call this the parallel component of Earth's gravity. And then, of course, part of it is holding, so if I can draw that, it's very hard to draw. I'm learning this, okay? And part of it is perpendicular to it, right? So this should be a right angle there, okay? The part that is parallel is a very important thing because that's what makes things slide down the plane, right? So I call that the parallel force, right? It's just part of gravity. And it is mg sine theta. And the reason that it's the sine of the angle is that these angles here are actually congruent. And so the hypotenuse is mg, right? This is the opposite side. And I'm just doing what? Sine theta equals opposite over hypotenuse. So therefore, opposite is h sine theta, right? So there's the hypotenuse is mg and sine theta, okay? So this guy's a player. This is, in any problem on an inclined plane, this is just a force acting down the plane, and that's how we're going to solve these problems. This part here is the perpendicular force, and just as sort of a novelty, we'll calculate this. This actually causes friction, but we don't learn that formula for IB, right? But this perpendicular component is mg cos theta. So let's just solve some problems with this, right? So here's this 5 kilogram object resting on an inclined plane, and it makes an angle of 26 degrees with the horizontal, right? And the first thing are, what are the components parallel and perpendicular? Well, parallel is going to be mg sine theta, right? So that's 5 times 9.81. That's a 9. Okay, times sine of 26. And this equals, I need a calculator. This equals, let's just try a 5 times 9.81 times sine of 26. That's 21.502 newtons. Now we only have 2 sig figs. I could just carry 4, but I'll carry 5 sig figs just for fun, because we're advanced students after all. And the force perpendicular is mg cos theta. And we're not going to use this one, but let's just calculate it for fun. 5 times, so I'm doing mg, right, cos 26. Make sure you're not in radians. See, that's always a helpful thing, right? So I'm so lazy, I'm going to go second entry and then hit cos, enter, and this guy is 44.086 newtons. I just rounded that to that, right? And this, we're not going to use this one, but if we were doing friction, it would actually cause friction, right? And then B says, okay, if it were to slide with no friction down the plane and no other force acting on it, right, then this force here is the only force, right, acting on this thing along the plane. And so we just say, hey, 21.502 newtons is acting down the plane, and we always make down the plane negative, up the plane positive. So I'm going to make that a negative force, right? And all our forces are just that force, right? Right. The parallel force is the only force acting, and that's 5 times A. And then, of course, I can solve for A, right? 21.502 divided by 5 is just a little more than 4.3, right? Right. We get a negative, that which just means down the plane, right? Ta-da. That's supposed to be a smiley face. Okay, let's do one that's just a little bit harder. Okay, so this one says what force, we're going to exert some force to make the block slide up the plane, right? So our forces are the parallel force, right, which is mg sine theta, which we've just figured out is 21.502 newtons, right? The perpendicular force is not acting along the plane, so we're not even going to calculate that, right? And so now we've got some unknown force, right? And we'll be coy and pretend we don't know it's up the plane, even though we know it'll end up being positive. This is the positive direction, that's the negative direction. 21.502 is down the plane, right? And so now our forces are unknown force minus 21.502 okay, equals 5 times, well, the acceleration is up the plane. Up is positive language, right? So that's going to be a positive 2.4, right? And that's, of course, going to be 21.502. We bring this to the other side and make it positive, right? Plus 5 times 2.4, 33. So F ends up being 33.502 newtons, right? That's a positive number. That means it's up the plane. Ta-da. Ooh, look at that. Okay, let's do another one, a little harder one. Okay, suppose red elk exerts a force of 31 newtons down the plane, right? So here's red elk. Okay. Elk antlers. Okay. Okay. He's exerting a force of 31 newtons down the plane. Okay. And the object accelerates at 6.8 meters per second down the plane. What other force must be acting on the plane? Well, that's not the only force, right? There's some other force, a mystery force, right? So we'll just draw that in here. I'm drawing it either way because we don't know which way it's going to be, right? We always have the parallel force acting down the plane, right? 21.502. Hold on. So that guy's down the plane, right? And so now our force looks like this. Our force situation looks like this. We've got an unknown force, right? And then we've got minus 21.502 down the plane, right? We've got the 31 newtons that red elk is exerting, right? So that's down the plane. So we're making that negative as well, right? Parallel force is always negative, right? And then that's our force picture, right? Unknown force, parallel force down the plane, right? And then that equals 5 times, and now we got to look at the acceleration, right? It's accelerating down the plane. That's negative language, right? So this is going to be a negative 6.8 meters per second, right? So negative 6.8, like that, right? So again, this is down the plane, that's down the plane, everything's down the plane. It's crazy, right? Okay, and then we can solve this. It'll be this times this, so 5 times negative 6.8, right? Plus 31 plus 21.502. And I get the force ends up being 18.502. Now the fact that it comes out a positive number means that it's up the plane. It's not ambiguous here, right? We don't look at this thing and go, gee, which way is that force? If it comes out positive, our convention is up the plane is positive, right? Down the plane is negative. That's a negative force, right? And the unknown force came out positive. That means it's definitely up the plane. It's not like it could be up or down the plane, okay? And then our final, let's do our final example here. The final one's got, suvat in here, right? We've got a push of 2.1 meters per second up the ramp, right? And it goes 0.42 meters up the ramp and stops, right? Okay, so what I'm going to do is let's just do a little cute little suvat problem over here. Okay, let's see. Its initial velocity is up the plane, right? Right, so it's a positive 2.1 meters per second, right? The final velocity is 0, right? And then the displacement is 0.42 up the plane, right? Right, this is meters per second, right? Okay, now, to be sure, if you stop moving up the plane, you've accelerated down the plane. Okay, so no matter how this plays out, we've got to make sure this acceleration is going to be negative. We just know that. But let's just see if our formulas give us that, right? So let's go v squared is u squared plus 2as, right? Okay, so we're going to plug this in. 0 squared equals 2.1 squared plus 2 times a times 0.42. Right? Well, of course, this is going to be a negative acceleration because when we put this on this side, it'll be negative. Then we divide by 2 and 0.42, right? So the opposite of 2.1 squared divided by 2 divided by 0.42. And I get the acceleration is negative 5.25 meters per second squared, just like we kind of thought it would be, right? So that's part one, right? Exciting part one. You'd think we're done, but we're not done. Now we got to solve the same sort of problem we've got, right? So let's look at this thing. There's a force down the plane always, right? Siempre, okay, of 21.502. This is the parallel force, right? Force parallel is mg sine theta, right? Which is 21.502 down the plane, right? So that guy's going to be negative. You've got an unknown force. I'll say I don't know which way it is, right? Okay, and we've got an acceleration down the plane, right? This guy, we're going to take this guy and use it over here, right? So now let's look at our force situation, right? We've got an unknown force, okay? Always make those positive, minus 21.502, right? And those are our forces, unknown force in this, right? Okay, equals 5 kilograms times this acceleration, right? Negative, ta-da, right? So 5 times the answer that I just got, plus 21.502 is the force is equal to negative 4.748 newtons. Well, that negative means it's down the plane, right? This is a down the plane force. The reason why I put this in parentheses is that I don't want to say negative down the plane and have some picky person say, well, negative down the plane is up the plane. This thing here means down the plane, right? I hope that helps.